Hello everyone, and welcome to another Willingdon Observatory live astronomy broadcast. I'm Terry Webb, and tonight we're going to see what we can do with the ATIK Infinity camera. The Society own one of these, and I've had it for a while, and generally I've been using it with a 5-inch refractor, but it's an 8-inch SCT. But both of those have quite a narrow field of view. So when you look at things like the Andromeda Galaxy or the Orion Nebula, they're too big really for the image, so people don't see as much as they'd expect to see. So one of the things we're trying to do is find a shorter focal length telescope, so it'll have a wider field of view. So at the moment we've borrowed one, and I'm trying it out. So hopefully this is a picture of what we've got at the moment. So the scope on the left is an 80mm Altair Astro ED telescope. It's not a triplet, it's just below triplet. It's got special glass in it. And you can see on the business end of it, we've got the Infinity camera. The ATIK Infinity camera is quite clever in that it comes with some software that allows you to live stack the images whilst it's taking them, which is quite clever. In normal astronomy, astrophotography, you take lots of pictures, images, and then you stack them yourselves later using some software. Then your stacking reduces the noise in the image, and you get a better picture. But this software can do it on the fly, which is really quite clever. So you can see we've got it set up. That's a picture from this evening, so that's exactly how it is now. I've been pointing at the Andromeda Galaxy M31 for quite a while to see what sort of image we get. So if I go to my laptop screen, hopefully it's the right thing in a minute. I've got this, so here we are now. So this is actually a picture of Andromeda Galaxy. If we come up to the top up here, we'll see that it's taking 5-second images. We normally talk about 2 minutes, 5 minutes, 10 minutes for an image. And then you take many of them and stack those. But this camera is quite sensitive. We take 5-second images and we're stacking those instead. So you can see here I've told it to stack the images. In actual fact, we've stacked quite a lot now because I've been on Andromeda for a while. So we've been doing it we've got 300 5-second images at the moment. And so that's 1500 seconds. So that's that's about 25 minutes, I think, approximately about that. And the software is pretty clever. It has some auto stretching functions. You can select different ones here. You can flip the picture. You can do various things. We've got it to calculate image movement. So generally, when you stack pictures, it has to align them in some way with stars. That's why you can't stack pictures of planets very well, because you don't see any stars when you get a picture of a planet. But what this does automatically is it aligns some stars so that it stacks the images on top of each other accurately. We can see from this image that you have the central part of the galaxy is very, very bright, so it sort of burns it out a bit. And we know the galaxy is sort of elliptical like that from this point of view. And you can see like a dark trail there and another sort of dark trail here. So this is dust and gas, which is stopping us seeing the stars beyond. The faint cloudiness in all this is actually stars. All these stars here, all these bright dots, are stars in our galaxy. So basically, the stars in our galaxy extend for quite a distance, of course. And then there's a lot of empty space, and then we get the Andromeda Galaxy. And so those stars are so far away, they just look to us, we can't see them, we can't image them at all. I mean, Hubble can now make out, and some telescopes can make out individual stars in galaxies, but our humble equipment, as opposed to Hubble, won't do that. So it's just a cloudiness, but this cloudiness here is actually stars. And this dark line here is dust and gas. It has spiral arms just like we do. And so you get this dust and gas and you can't see the stars beyond that. So that's why it sort of gives you this light, dark sort of view. Like I said, this is 300 odd stacked images. Okay, so if I just go back, so this is the good image. If I go back now and tell it to stop stacking and reset, hopefully, let's just stop that and start it again, see what happens. I'm hoping now we'll just get a single 5-second image. So that's a single 5-second image. You can see lots of noise in the picture here. Yeah. So this is what stacking helps with. Stacking gets rid of all this noise, because this noise is random. So it means that your next picture, the noise will be in a different place. So if you keep stacking pictures, you eventually get rid of a lot of the noise. Can't get rid of it all, but you just reduce it. So we start stacking pictures now. So this is just one 5-second image. We'll tell it to start stacking. So now it'll start stacking images, and hopefully we should see the background sort of get better. Yeah, there we are, straight away. Yeah, and it changes faster earlier, and of course, but as time goes by, it does keep improving slightly. So the fastest changes happen in the first few stacks. And you can see straight away that you already see the dark lanes here, a dark lane there, and we've got the central core of the galaxy. So this software is pretty good. The image field of view with this telescope is quite good for Andromeda. It isn't. It's still a bit too magnified for Andromeda. Andromeda stretches a bit further out than we've got in this image here, but this is pretty good for showing to people on public outreach, which is what the camera's for. So it actually is for doing public outreach and showing people what you can see through a telescope that you can't see with your own eyes. So that's how you use the ATIK Infinity. This is the ATIK Infinity software. It's called Infinity, and it does. You can even record sequences. You can save images. If you record the sequence of images, you can play them back and actually play around with the image settings. These things up here, so you can change the black and white points and balance of various things, which is quite nice to do. But you can sort of play on the fly and then try it again afterwards to try and get something better. So that's what I'm going to show for the moment. And I'm going to stop this, and we're going to come back, and hopefully we'll see the moon. And then basically later on I might see Orion, but I'm going to try the moon next. So bye for now. Okay, everyone, we're back. As we said, we've just been looking at Andromeda, and I've now moved my scope so it's on the moon, and we've got the moon in the view of the ATIK Infinity now. Let's go straight to that again. So let's do that, and then over here. So here we are. So here we are again. So now we've got the moon in view. If we go back up here again, I'm now taking exposures at 1,000th of a second. The moon is very bright. In fact, there's only one thing brighter, of course, that's the sun. It's currently a sort of a gibbous moon, so it's getting brighter and brighter. It will become full moon in a few days' time. Generally, you don't want to look at the moon when it's too bright, because it's too bright. It drowns out all the other things in the sky, like the deep sky objects like Andromeda Nebula. I know we've been looking at that, but it would be better if the moon wasn't around. But this is what it is. And if you see the moon when it's full, basically that's the worst time to view the moon, because the sun is shining directly at it and there will be no shadows. But when the moons are in a phase like now, or basically first quarter and second quarter, so first quarter and last quarter, about the best times to view the moon, or when there's smaller crescents, you get more detail, because you get detail then where the sun's terminator is. So on this picture here, this line here you call the terminator, and it's where the sun is hitting the moon at 90 degrees, so you get the longest shadows, 0 degrees. So you can see, right, when you get down here, you can see there's a lot more detail in these craters here than there is in craters up here, because the shadows are better. I mean, if I zoom into this area here a little bit, you can see that the actual image shimmers or wobbles quite a bit. This is due to the Earth's atmosphere. The Earth's atmosphere sort of refracts light as it comes through it. This happens for all things we view in the night sky. But it seems to affect things like the planets and the moon far more, because they're not points like stars are. So you see all this shimmering and wobbling. Taking pictures of the moon this isn't very good for taking pictures of the moon again, because it's not a video camera, although it is taking very fast exposures. And this isn't stacking, because it can't stack this because there's nothing to align it against. There's no stars in the background that it can use to make sure the image fits on top of it, the next image. And that's the way that other software for stacking planets and images of the moon work. They align on things within the actual image themselves. But this software can't do that. Maybe it can in the future, but it can't do it at the moment. So you can't get any better pictures of the moon, really. But at least you can see plenty of different craters on it. And you can see the idea of the fact that when you have this terminator, you get more detail because of the longer shadows. Let's just go back again. We all know the moon. These things here are called seas. Sea of Tranquility is one of these. But this is basically big basins of lava from billions of years ago when the moon formed. Or these are probably a bit more recent, because there aren't as many craters in these. If you look at all these bits here, there's plenty of craters to be seen because they're older. The newer the surface, the less craters there are. I mean, if you look at this one here, let's zoom in again. You can see there are craters inside this. So it has been hit since it was formed, but these have all actually got craters inside them. This just isn't showing them up well enough. But they're more recent surface features than these sort of areas. That's one way you can tell the age of things. Okay, so that's a bit on the moon as well. The plan now is to possibly see Orion later on. If it is, I'll come back and show you Orion. If not, then this might be the end of it. So anyway, bye for now. Okay, everyone, I'm back, but not with Orion. Orion's not up yet. And so on the way there, I thought we'd pass the Pleiades, M45, or the Seven Sisters. As I'm down south, the Seven Sisters mean something down here. So let's immediately go back over to the ATIK again. Let's find the right. I'm doing the wrong thing, you know. So. All right, here we are. So I'm back here again. Sorry, this laptop screen. I think I might have messed things up earlier. But anyway, let's see what we got. So laptop screen, go to here. And here we are. So here's a picture of the Seven Sisters. I'm currently taking 30-second exposures. And I've got it set to this auto ranging of low. So you can't really see too much there. However, if I change that to the next one up, medium, we can now see that something that you get on long exposure photographs, you get a lot of nebulosity around the stars. You can see the dust, gas. I know the stars are bloated a bit now, but you've got the dust and gas there, and that's quite useful. So you see around here all this dust and gas, and there's a bit around this one as well. I'm not sure of all the star names, but these are like the 4 main stars and a couple of others for the Seven Sisters. And you can see a lot of noise in this picture because it's been stretched a bit too much for what we want to see, but because it shows this nebulosity, so this dust and gas, it's a nice thing to do. So that's M45, the Pleiades, or the Seven Sisters live stacking. So at the moment we've done 35 exposures of 30 seconds each. for that image. So let's, once again, I said we'll go back to Orion later on, hopefully. So bye for now. Okay, everyone, back again. This time I've decided to look at the Crescent Nebula in Cygnus. That's NGC 6888. We all remember that, don't we? Anyway, the Crescent Nebula is in Cygnus, so that's the constellation of Cygnus the Swan. Now, it just so happens that Cygnus is sort of lined up with the Milky Way. It's in the Milky Way. It's not the centre of the Milky Way, of course, but it's close to the centre. So if we go straight to our laptop screen again. So first of all, we'll go to some software. So here's some software called Stellarium, which one of the software I use, one of the planetarium software I use. As you can see here, here I am at this time of night. We're looking directly west. Here's Cygnus, you know, the constellation of the Swan with its the head and the tail and the wings. And here's the Milky Way going through. As you go further that way, you go into the outer reaches of the Milky Way. As you come this way, you're getting closer to the centre of the Milky Way. The centre of the Milky Way is in Sagittarius, which is out of view at this time of year. And you see the moon's over here at the moment. It's not causing too many problems, although it is still very bright, of course. So we zoom into Cygnus. We've passed lots of things. So here you see all the Milky Way and dark bands that you get because of dust in the Milky Way. Zoom in a bit more. Here we are coming towards the centre of Cygnus now. So here's an image of, this is what the Crescent Nebula looks like in a really good image. This is the size of my sensor in ATIK Infinity at the moment, so that's the sort of view I should get. But we'll see what we can see. So we'll immediately flip over to our camera and see where we are with the camera. So here we are now with the camera. Again, I'm taking 30-second exposures and I'm stacking them, and I've got it on this auto stretching medium at the moment. And we can see here it is. Here is the Crescent Nebula. Yeah. And differently from the earlier pictures, there's one big difference here. There are thousands of stars in this picture, as opposed to a few. And the reason for that is simply because we're looking into the plane of the Milky Way, which is where the vast majority of the stars of the Milky Way are. We all know it's like a disc sort of shape with a sort of a lump in the middle. So as you look along that line, you see thousands and thousands more stars. If you look at 90 degrees to that, you're looking out of the plane of the Milky Way. And of course, therefore, you don't see as many stars. And this is why this image is just full of stars. And you can see the Crescent Nebula here. It's this reddish sort of thing. If we keep going, we might get sort of the egg sort of shape, but we might not, because it's a lot fainter on this side of the nebula. But we can see lots of gas and dust on this side here. So that's quite a good image, really. A lot of things are different types of gases emit different colours of light, depending on the temperatures and things. So yeah, we know stars have different temperatures. Well, the nebulas have different colours. Some are reddish, some are greenish, depending on what type of gas they've got in them and and therefore what frequency of light they're emitting. So there are emission nebula and absorption nebula, which show different colours. But just another amazing picture from the ATIK Infinity. Once again, although I'm taking quite long exposures of 30 seconds, it's still easily doable for public observing. This is 500 seconds in total at the moment, so that's only, what's that, 10 minutes. So that's quite good. Once again, we'll say goodbye for now, and we'll hopefully be back later. Welcome back, everyone. After quite a wait, it's now 12:30, and it's a bit colder. We now have the Orion Nebula in view. It's risen and come up from behind some neighbours' trees. so I can get the ATIK camera onto it at last. So without further ado, let's jump straight over to the ATIK camera. So here we are. Right, so how is that then? So here we are now, we're looking at the Orion Nebula. We're currently running 1 second exposures, and we're on 245 of them, so we're coming up to about 5 minutes worth. As you can see, it's looking really good. The stars in the middle always blow out. It's really, really difficult to get a good picture of the Orion Nebula with just one type of exposure. Generally, to get a really good picture, you need a separate exposure to get the middle bit. This area here has some very bright new stars. One of them's called the, oops, I forgot what it's called now. It's the shape of the stars is in a sort of a quadrilateral. So if I change the settings here, hopefully, I thought it was going to be hopefully, I don't know why, full range. See here that these are the bright stars in the middle that are causing the issue. So if we can get back to here, you can see there again that although they blow it out, you can see lots of dust and gas. You see the fronts here from dust and gas. It's a pretty good picture, and the image size is good as well. That's one of the things I was looking at, was the size of the telescope compared to the camera, and see what size the image scale that came out. That's a nice image scale for the Orion Nebula. So I think it's a good fit for what we're looking for. Okay then, that's it, I think, for tonight's observing and viewing. Once then, Orion Nebula, really good. Just to show what the Orion Nebula is, we'll just dive over to Stellarium. And here we are. So here we are. So that's the Orion Nebula. Sorry, the Orion constellation. That's Orion. Here we zoom in down. There's the belt, and then M42, which is the Orion Nebula, is this area here. So that's what we've just been imaging. Okay, so that's called the Sword of Orion. That area. When you look at it, it looks like 3 stars. Well, as you can see, when you start zooming in a bit and seeing some images, it's not 3 stars. It's actually, the middle piece is all this nebulosity called the Orion Nebula. Now, let's just finish by going back to the image again from here. So there's the image. Thank you. Let's do this. So, thank you and good night, and see you next time.